Hey everybody, welcome to topic number 3. I'm talking about qualitative data and graphs. So in this video, I'm going to show you some display of qualitative data and the graphs associated with it. So down here below are two different tables comparing the number of part-time and full-time students at these two colleges. Okay, so the table display counts is called frequency. So this number right here, the count is also called frequencies. Okay, so I will begin to use the word frequency a little bit more often. And the percentage, okay, and this percentage, okay, is also called proportions or relative frequencies. Okay, so percent, relative frequency, and proportions, they're basically saying exactly the same thing. Okay, percent. All right, so the category, our category here are part-time and full-time. Okay, so for example, a pie chart is a very good display, okay, for qualitative data. So in pie chart, category of data are represented by the wedges in a circle and proportional in the size of the percent of individuals. So this 59.1%, this wedge, okay, is accurately represented as the part-time students. Okay, that is displayed in the table. The 40.9%, okay, are the full-time students. So in the pie chart, we want to make sure these wedges are actually proportional, okay, in size to the percent of individuals in each category. And this percent can be found by simply take the frequency, the number, divided by the total, then times 100. So we'll do an example like that in a minute. Now, in order to, we'll do that in a minute. There's another one I want to show you here too as well. All right, so pie chart, very good display for qualitative data. Another good display, another good graph is called a bar graph for qualitative data. Again, the length of the bar for each category is also proportional to the number of percent of individual in each category. So the length of these bars are still also proportional to the percentage. Okay, another display, we don't see it very often, it's called a Pareto chart. Pareto chart consists of bars that are sorted into order by categorizing the size, okay? So the larger size, go from large to small, the larger size, this particular example here, larger size is actually listed first and it go in a descending order like that, okay, called the Pareto chart. Now let's do an example here with a pie chart. The pizza pie and go sells about 2,100 one-topping pizza each month. The circle graph here representing the most requested one-topping pizza by percentage. Okay, so these wages right here, okay, is actually proportional to the percentage. Find the number of a pineapple pizza sold. So pineapple is 26%. So pineapple is only part of that 2,100. So to find how many pineapple pizza is sold, we need to find the parts, which is percent times the whole. Because the pineapple is part of that 2,100. And percent here got to be in decimal notation. So the 26% is a percent notation. In order to become a decimal notation, we have to divide it by 100, which is 0.26. So percent in decimal notation, 0.26 times the whole, which is 2,100. If you put that in the calculator, 0.26 times 2,100, that should be 546. All right, so there should be 546 pineapple pizzas sold that month. Okay, because pineapple is a part of the 2,100. So in order to find part, we take percent times the whole. All right, take a look at this bar graph. This bar graph shows the per capita personal income for 6 states. So per capita personal income is almost like the average income for the entire state. Okay, that's everybody in the state. Doesn't matter rich or poor, add them all up, divided by how many you added. So if a single resident of New York State makes $60,000, so the average, so everybody together is makes about 57,000 per capita personal income. A single resident is making 60,000, so 100% will be exactly 57,705. 60,000 is a little bit old, it's a little bit more than 57,000, so your 60,000 in terms of percent is actually going to be over 100% because it's more than 57,000. So the question asks, what percent of the of per capita personal income is this one? Is this resident? So in order to find percent, like I mentioned earlier, you always take the part divided by the whole, then times 100. Because this single resident is part of all those averages, it's part of that 57,000, right? 57,000 representing everybody, all the income in the state of New York. So this 60,000 is only a part of that whole thing. Okay, times 100. So if you put this in the calculator, 57,705, then times 100, you should get 103.977.125 something. Round to nearest 100, so that'll be 103.98%. So if the question asking for percent, make sure you write a percent notation. Otherwise, it will be incorrect. Okay, so make sure you write the percent notation for the final answer. All right, let's look at the homework. In a what category of data are represented by wedges in a circle? So you can find the answer in your handouts. In a what, the length of the bar, each category is proportional. So in a bar graph, right? A what consists of bar that are sorted, a Pareto chart. So the question 1, 2, and 3, you can find the answer. Okay, you can find the answer from the handouts. All right, question number 4. Okay, this time, same picture. This time I want you to do beef pizza. Okay, find the number of ground beef pizza sold. All right, and this one right here, same picture as from the same picture, but this time I want to do Alabama. If a resident of Alabama makes 20,000, okay, Alabama is right here, 20,000. So 20,000 is less than the average here, right? So everybody in Alabama makes about 38,000 on average. So 20,000 is less than that. So when you find your answer should be less than 100%. Okay, make sure you round to nearest 100. Make sure you write your percent notation. So just real quick, talking about what does a qualitative data looks like in terms of table and the graphs that associate with qualitative data. All right, that will conclude this video. Thank you for watching.